What's up, bosses? I'm JoeMan543. Welcome to the stream tonight. It is Wednesday. It is math night. Yeah. As of a few weeks ago, I've started doing math streams on Wednesdays because I'm a college student and I'm getting ready for a test. And if I do well on that test, I can skip a bunch of math classes. Instead of going through a bunch of classes, I do a bunch of studying on the side and then just take a test, do really well, and skip up to a higher class. So that's what's going on tonight. So, but before I get into doing math, I'd like to welcome everyone that's here right at the start of the stream. Welcome, Jacob Robert Castro. I'm going to turn the volume down just a tiny bit. Jacob Robert Castro, Noobified, DGC Pictures Entertainment, and Insane Gamer. DGC Math Joanne! More like Joe Math, right? Yeah. Joining me tonight, I have a few baby carrots left that I was snacking on, and a dollar store jar of dill pickles. Breckenridge Farms. Sounds like it's trying to be Pepperidge Farms, but it's not. Anyway, got some dill pickles I'll be snacking on because dill. Also, they're from the dollar store because dollar store. I've had a few. They're good. So, anyway, yeah, we have math tonight. So, let me pull that up real quick. Let's see. Get it right here. Okay. So we're gonna hop in here. There we go. So last time we filled out this portion of the circle, real numbers. So we know all about real numbers, you know. Fake numbers, forget about it. But real numbers, we got that. Gonna give you some carrot crunch ASMR. Carrots are good, man. Make me think even better, which I will need it. And then, as you can see, we're getting close on several of these other sections of the pie. These blue sections are the smallest, but yeah. So I don't have to fill this out necessarily, but obviously, the further I get along, the more studying I do, the better I'll do on the test that I will be doing later this week. That said, I may not be doing more of this math live streaming. This might be the last one, because if I do well on the test, I test high into a class, and then my professors say, don't stream your homework, which makes sense, because if I'm streaming homework, I could be giving out the answers to that week's homework. Yeah, this might be the last one. So, I don't know. We'll see. Mathster Chief back there with you, I see. I guess on this cam, you can't really see. Yep, there he is. Mathster Chief. I need a bendier arm. Yep. And then we got little Chief here. Banana. No, banana. Hanging from back there. Yep. Okay. I watched like 4 of your streams the past few days, and they're great. Thank you, Insane Gamer. And welcome to stream. The Arbiter, but drunk. Yo. The Arbiter, but drunk. Okay, let's see. So my wife works at a dental office, and she keeps bringing home pens. So I'm kind of well stocked. These are the Pilot G2 pens. They're really good. Pilot G2 10. They've got great flow and all that. I like them. Anyway, we need to kind of get in position here to do some math. So, well, first of all, let's continue here. So I have that pulled up. All right, we're bringing pi out. Solve for h. Yeah, that looks fun. Okay, I need to rearrange some stuff real quick. So first, oops, that is. Uh-oh. We got Y, Joe Man again. Okay, no. That's not right. Isn't it supposed to be about there? Whatever. I think I might have broken it. Dang it. Oh, there we go. That's normal proportions. Okay. No, that's not what I want. The hotkeys seem to have changed. Weird. I think we can still get this to work though. So. Well, this is just weird. I'm gonna try something. Yeah, we're gonna just remove me entirely. I'll be back, don't worry. Okay, here I am. Okay, there we go. Now I can crop this in like normal. One thing we have to do is flip me upside down. And we need to drag the math over to the side here. I'll make it a little bit bigger. Alright. Get it just right. Okay. Right. And then a water bottle. Actually use the water bottle to mount the camera so that I can look at my book. There we go. All right, so that's math we did before. Let's get a new sheet here. Okay. And then obviously this needs to get a lot bigger. So perfect. Let's see, and then we can focus in even more here. Well, guess that's about as much as we'll get. I guess I could do that. I swear, every week oh my goodness, I didn't know I could do that with the camera. That's way better. Okay. I swear, every week I'm learning how to stream. Every single week. Okay. Well, now that I have figured that part out, yeah. Oh, hey, look, I'm live now. Just getting a notification to my phone. And eating a carrot. All right, math, so. Solve for h. Enjoy my carrot eating. So in this equation, since pi is you know, one of those special numbers that goes on forever and ever, looks like we just treat it like a variable, like we would x. So we minus 2 pi r squared from both sides, which gets rid of it on one side, but then we have the negative version on the other side. Then we divide both sides by 2 pi r, so that h gets alone. And then h equals s minus that over that. Simple enough. So basically, solve for h, and pi acts just like a regular variable. Got it. So I assume if your professors give you another subject to do, they're going to forbid you from doing a stream. Probably. Here's the thing. I've tried doing math for years, and the stream is the most consistent I've ever been with math. I've tried reminders. I've tried like little rewards and snacks and stuff. Nothing has worked. Doing streams has been the best thing for me doing math. Nothing has been as effective as streams. So I want to keep doing them because it has been the best thing for my math. So anyway, so our problem, we got f, and we got a pen that doesn't want to write. We got f equals mv squared over r. And we are solving for m. Okay. So the first thing I'm going to do is multiply everything by r. And so, let's see. Should I go sideways or down? I'm going to go sideways. So that's going to give me fr equals mv squared. And then m needs to be alone. So then we're going to divide the whole thing by v squared. And that's going to give us fr over v squared equals m. Yep, simple as that. I'm going to eat my carrot. You've been studying a lot, man. Impressive. Thank you, Elgato Kriki. Thank you. I think, let's see, 2 hours, 4 hours, 2 hours, because I had that one. Have I done 3 or 4 of these streams? I am going to check right now. How many math streams have I done? Let's see. So, 2 hours last time, 4 hours before that, 2 hours before that, and that's it. So, I have done 8 hours of streamed content for math. 8 hours of math so far. I should be good at it. Okay, so m is going to equal fr over v squared. Those are just letters. I don't understand the slightest. Yeah, literally the only number here is a squared. And we don't even say it as 2. We just say it squared. So we're not even recognizing it as a number. Okay, I think that's right. Awesome, it is. We're starting off good. I'm going to eat the rest of my little baby carrot. You know, I like to munch my way through it. And this is the last bit of the baby carrot. Excuse me. Oh yeah, I'm a professional math streamer. Yeah, professional right here. Focus my camera. Okay. So, it's gonna be a lot harder. Wait a second. Okay, this is just annoying. This isn't y squared or whatever. It's just y1 and y2. Like, this could be a and w. Like, these y's have nothing to do with each other. Alright, whatever. Let's write the problem down. Whenever my pen sits for a little bit, it gets some ink hanging off the end, so I always get a big glob. And I write with it again. Let's see, so we got y2 minus y1. Like, seriously, y2 and y1. That's just annoying, man. Especially once we get into, like, logarithms and stuff, which, well, we haven't gotten into. Because logarithms use the little space down next to the letter. Logarithms use that space, man. Okay. So, what am I doing? Jacob Castro, I'm 11 years old now. Well, what's the word? Oh my goodness. Happy birth. Congratulations. That's wow. Glad we're not doing English tonight. Yeah, congratulations, Jacob Robert Castro, for watching a math stream at 11. Definitely wouldn't catch me watching math at 11 years old. Okay, so the first thing we need to do is take these x's and put them over there. So we're going to multiply all this by x2 minus x1. It's so annoying. It's not x squared, it's x2. It's not even like x2, it's the second version of x. Anyway. Okay, so that's going to clear this out. But then, see, this is where they're trying to trick me up. So we got mx1 minus mx2. I'm trying to solve for y2. So y2 minus y1 All right, then we need to plus y1. So I'm going to write it down here. mx1 minus mx2 plus y1 equals y2. It's just so dumb. I got it. y2 equals y2. Yes, technically. Okay, so let's check my math real quick. It's not even numbers. Okay. How do I even write this? mx. I gotta use subscript here. 1 minus mx2. Too bad we don't get it up to mx5. You know, because I drive a Miata and it's a lot of fun. Okay, I think this is right. It is not right. All right, so I messed up somewhere. Oops. So, what do we got here? So, first of all, so we started with this. We wanted x2 and x1. Oh, that is where I messed up. I swapped x1 and x2. That is where I messed up. So really, it should be mx2 minus mx1 plus y1 equals y2. That is where I messed up. mx2 minus mx1 plus y1 equals y2. I think that's it. Okay, that is. Seriously, most of the time I mess up, it's because it's a simple mistake like that. All right, so we're gonna solve this next one for m. Still got a lot of space here, but my microphone is always in the way when I get down here. All right, let's see. So E equals mc squared. Dang it. E equals 1/2 mv squared. 1/2 mv squared. Interesting. So it's like m over 2 v squared, right? Well, we're solving it for m, so so the first thing I'm going to do is multiply everything by 2. Multiply u by 2. 2e, or not 2e, equals m v squared. And then we're going to divide by v squared. So we get 2e over v squared equals m. Simple as that, I think. I hope. Cool, bro. Did I figure out what you did on the last one? Well, technically y2 equals y2 is true, but also mx2 minus mx1 plus y1, that also equals y2. So, all right, for this problem, 2e over v squared equals m. Awesome. All right, we got one down. What are the degree and leading coefficient of the polynomial? All right, I give up. All right, not really, but you've thrown a lot of vocabulary at me. All right, I need a pickle. I need a pickle to snack on. So I don't really want to like reach into the vinegar, but hey, what you gonna do? Just know I'll be snacking on a pickle. The camera's gonna keep pointing at the paper though. All right. So we have a thing here, polynomial. Polynomial just means lots of nomials. What's a nomial? W. W is a nomial. So yeah, So, what are the degree and the leading coefficient? I think leading coefficient would be w to the fourth. Oh, I have no idea about degree. So, first, rewrite in standard form. Ah, yes, standard form, yes. That just means rearrange it from biggest to smallest in terms of the exponent. So we rearrange in standard form, biggest to smallest. The leading term is the first term. Oh, really? When the polynomial is in standard form. So leading coefficient up here, leading term down here. So for the polynomial, the leading term is that one. Degree. The degree is a term. Oh, the degree of a term is the exponent of its variable. When there is no variable, the degree is 0. Exponent of its variable. So 4, right? The degree of a polynomial is the degree of its leading term. For our polynomial, the leading term is that, so the degree is 4. Man, they throw some vocabulary at you. Instead of degree, they could have just said, what's the power? What's the power of the leading term? All right. All right. And the leading coefficient is negative 23w4. Oh, so the leading coefficient is negative 23. So the coefficient is just a number. The term is that whole thing. Okay. So degree is 4, which has nothing to do with degrees of a circle. And the leading coefficient is that. All right. Pickle. Pickles are good, man. All right. Degree and leading coefficient of the polynomial. So, I feel like I could do this without even writing, but I'm going to write this first one at least. So 3 minus 2u to the third minus 4u to the fifth minus 10u. Yeah, so we just rearranged that. So the biggest exponent one is this negative 4u to the fifth. And then 2u to the third. 2u to the third minus 10u plus 3. Sorry, my microphone hit my headphones a little bit. All right, so pickles. So basically, that's our degree, and that is our leading coefficient. So, degree, 5, leading coefficient, negative 4. Simple as that. It's just vocabulary, really. Sorry, I got some pickles stuck back there. All right. Get out of there, pickle. All right, one leading coefficient and degree of the polynomial. Really, it is that easy. Just find the biggest exponent. Boom. I almost messed that one up because I swapped the order on me. All right, leading coefficient, negative 2, degree 3. Kaboom! All right. All right. Sorry, that's pretty good pickle. But a lot of salt and vinegar. I probably won't actually eat a lot of those because my water bottle is the thing currently holding up my webcam. So I won't be able to get a drink of water very easily. Okay. Find the surface area of a cylinder with a base diameter of 8 meters and a height of 9 meters. So pi r squared, right? So pi times 16. So the surface of the cylinder is made of 3 regions. Oh, the surface of the whole cylinder. Okay. Okay, so yeah. So what we know is it's pi times 16 for 2 of them. Okay, then that's where things get hard. Okay. So how do we do this? The surface of the cylinder is made of 3 regions. 2 bases are circles, and the third region is a rectangle that has been rolled up. Yeah, that makes sense. So, and we know the height here is 9. So, that's cool. So, the area is going to be pi r squared plus pi r squared, right, the two ends, plus 2 pi r h. Wow! Okay, I got to write that down. So, a lot just got thrown in there. So area of cylinder gonna do the pi r squared plus, got some hiccups, pi r squared plus 2 RH. No, 2 pi RH. Okay. It's a lot going on in there. I mean, it's one side, the other side, and then the cylinder that actually connects them. I apologize. All sorts of things going on tonight. Numified. I used to remember when certain math tests would add in real names for their questions, and they always use the name Joe or John. I mean, dude, Joe is a cool name, right? Pretty cool. Okay, so we plug this in. So yeah, our radius is half the diameter, so 4 squared, that's 16. So pi 16, or 16 pi plus 16 pi plus 72 pi. Boom. And of course, because we're looking for surface area, it is meters squared. Yeah. So if you had a barrel, let's say it's a 50-gallon barrel, and you needed to know how much paint to paint that barrel, this is how you'd figure it out. Like, I wish they'd give a real-world example. It's just like, oh, here's a cylinder. No, it's like, you're a hillbilly with way too many barrels in your backyard, and they're starting to rust. So you have the means to remove the rust with a wire brush, but you need to paint them so they don't rust again. So here's the dimensions of the barrel. How much paint do you need to, coat the barrel, to paint the barrel? Real world stuff. Okay, I'm getting distracted. Let's actually jump in here. So this one is going to be pretty similar, actually. I'm going to bring my water bottle on top here. See my shirt. My shirt down here. Oh boy. Things are getting out of control. Let's see if I can actually bring the camera back. Oh, come on, work with me, camera. No. No. Okay. I think we got it. So, let's write this down. So for this one, Black Kaiser Drake, welcome to the stream. It's actually math homework. Yeah, it is math homework. Okay, so for pi, hold on. Write your answer in terms of pi and be sure to include the correct unit. Wait, are you saying use 3.14 or use pi as a variable and just leave it at that? I have a feeling I'm going to get annoyed at this because I already am. All right, let's actually write this out. So our area is going to equal pi r squared, and our radius is going to be 4 plus pi r squared plus 2 pi RH. So 2 pi radius and height. Okay, so with that, we can break this down a little bit. Let's see, so it's going to be 16 pi plus 16 pi plus 20, is that 40 pi, basically? 40 pi. So 16, 32, 72 pi. I think this is what they're looking for. I don't actually break it down into about 3.14 times that. All right, so I think they're just looking for 72 pi square feet. Maybe. Yes, they are. Okay. Yeah, sometimes what it's asking for isn't entirely clear. It can be annoying. I'm going to blow my nose real quick, and then we can do this next problem. Getting a lot of ASMR. Getting some carrot eating, some pickle eating, some nose blowing. And I realized just now the music has stopped. So, why music? Okay, let's get music going again. I'm gonna turn it up just a little bit. Alright. There's a new mod in Halo called Ruby's Rebalance. That is not a new mod. It's been around for a while, I think. I was watching Ruby of Blue telling cool stuff in this mod. Cool. Alright, well, back to math. We got enough room here for just a little bit more. Okay, so kind of the same deal. We just gotta plug in our formula. So we're gonna do our pi r squared. I might skip a little bit here. Well, we have to do some 1.5. Oh wait, no, it's already giving us the r. Okay. 9 pi, because I already know what 3 squared is. Let's see. Okay, I will actually need to write this part out. RH. Let's see. R. H. Perfect. So A is going to equal 18 pi plus, let's see, 3 times 7, 21, 42 pi. Man, what's up with my nose? I got blowed again already. Add those together. That'll give us 60. Simple as that. 60 pi square inches. Awesome. The arbiter but drunk ASMR. Yes. Alright, I learned 2 things. Hooray. I gotta blow my nose again. Nose. Why? I know the whole trumpet thing sounds silly, but it is extra effective at clearing the nose. So, if you ever heard your dad do it, it sounds silly, but he's smarter than you. So, okay, multiply. So, you take this lefty thing and put it on the righty thing. But to do that, you take your 5u and you doop-de-doop-de-doo. You take your other thing, the 1, doop-de-doop-de-doo, and then you get a bunch of numbers out of it, and then you combine like terms. In other words, negative 30u plus 5u, you get a negative 25u out of that. So you can just combine your thingies, and that's your answer. Pretty simple. I'm going to need a new page here. Holding my microphone and my camera, holding all the things. Now we're actually gonna get down here. Okay, So, yeah, this looks fun. 4u plus 7y minus 7. 6u minus 4. Okay, there's two ways I can multiply this in. I can either do like that into there, and that into there, and that into there, or that into there, and that into there. So I'm gonna, flip it around. It doesn't matter. It's fine. So I'm gonna do the 6u first. So that's gonna give us 24u plus 42 yu, or uy. I don't think it's gonna matter. Let's see, minus 42u. All right, then this -4 minus 16u minus 28 y, yes, 20y plus 28. All right, we just got a nice long thingamajig there. Let's shorten it up a little bit. Actually, I've already messed it up. Okay, so -42u and 24u and 16u. How did I end up with this many u's? Hold on. Oh, that should be u squared. That's how. Right? Yeah, okay. Almost messed up. Jacob Castro. Just a picture of a carrot. Alright. So, there's no other u squareds. So 24u. I was onto something here. 24u squared. That'll stay alone. And then we don't have any yu's. So that's gonna be as it is. Alright, and then we come here to the actual u's. 58 u. Wow, there's not really a lot of combining of like terms here. That is the simplest form it can go into, which is really long. But that's how it goes sometimes. So 24u squared plus 42yu minus 58u minus 28y plus 28. That's a long answer, man. But it's a right answer. All right, this song is the math thinking song. So I will definitely get this next one right. Oh, the misplaced confidence. Okay. The arbiter bread drunk. Carrot and pickle. Hey, not a bad combo. All right, multiply again, except we have 3 and 3. So this is where the fun begins. Write out the problem. Okay. Doesn't matter which side I start with, so let's start with the 5 here. Got 10 w squared minus 35 wy minus 5, no, yes, minus 5w plus 6 wy minus 21y squared minus 3y. Moving on to the 2 here, plus 4w minus 14y, almost at the edge here. Let's see, minus 14y minus 2. Seriously, whole page, almost. Okay, so w squareds and y squareds are pretty much left alone. So 10w squared. I'm gonna bring the y squared over just so it's like kind of, it's in standard form. Yeah, that's the word. Minus 21y squared. Okay, then we're gonna do the wy's. Minus 29 wy. Yeah, I'm gonna get confused, so I'm gonna just barely cross out each of my things here as I use them. So wy's are gone. Okay. Then w's, minus 5 plus 4 minus w. Then we have the y's, minus 17 y. This is just torture. Minus 2. So long. Jacob Castro, you're doing great work. Thank you. Thank you, Jacob. Minus 21y squared. Minus 29wy. Minus w minus 17y minus 2. I hope this is right. It's not! Uh-oh. Alright, where did I mess up? I hope it's not just the order, because that would be annoying. Okay, so first let me make sure I multiplied this out correctly, and then I'll check my simplification. So, those two positive 10w squared. Well, first I'll make sure I wrote it down. I wrote it down wrong! I wrote it down wrong! Ah, I've done this before. It's a negative, not a positive 3y. All right, well, found my problem. So let's rewrite this here. 10w squared, because this is wrong now. Yeah, 10w squared minus 35wy minus 5w. It's a negative 3, not positive 3. Gotta write it the correct way. Let's see, so negative, yeah, minus 6wy plus 21y squared plus 3y. And then the 2, the rest will be the same here. Plus 4w minus 14y minus 2. Okay, and then let's do this right here. So the 10w squared, that's gonna stay alone. It's MathMan543, hard at work as always. I think you mean Joe Math 543, albino buffalo. Welcome to the stream. Okay, 10w squared. What are we doing with this? All right, so that's the only w squared. So that's been used up. Plus 21y squared. Write it biggest to smallest as far as the exponents go. Standard form, you know. Henry Marshall, welcome to the stream. All right, then we have our w's. No, we have our wy's. Negative 35 minus 6. So negative 41 wy. We used up our wy's. Then our w is still minus w. Okay, then we just have our y's over here. Yeah. So plus 3y minus 14 is minus 11y. Minus 2. All right, there's our new answer. Taken forever. The 10's fine. This is going to be plus 21y. And this one's going to be minus 41wy minus w minus 11y minus 2. Hopefully that got it. It did. Okay. That got that. Make sure I write down the problem correctly. I'm going to blow my nose again. I don't know what's going on with me. Maybe it's just too much math. Maybe I'm allergic. Excuse me for blowing my nose, I guess. Okay, so let's math this thing out again. I'm just going to sort of start by rearranging this. We got W and U. Better than X1 and X2. That was so dumb. Minus 7U. Minus 4. Okie dokie. So I'm multiplying this out. 6 to 4. 24. You know, that one started out with 24 as well. This will be squared. This is almost the same problem as before. You can see up here, 4u minus 7y minus 7. 4w minus 7u minus 4 times 6u minus 4 times 6w minus 3u. Yeah, it's pretty similar. I mean, it's different enough, but yeah. Okay, back to this. I'll bet Aunt Sally has something in her stash that can help you with your nose. Aunt Sally. Dang, Aunt Sally. Okay. So 6 to 4 is 24. 6 to 7, 42. You know, I'm just going to double check that I have everything written out correctly. Okay, I do. 42. W-U. 42 woo. Minus 24W. And then the 3. Plus 12 WU. Minus 21 U squared. Minus 12U. Okay. So, just double checking. Yeah, I think I got that right. So, now let's simplify that down. 4w squared. I'm going to pull this minus 21u squared over here. Once I've used it, I'll cross it off. Then negative 24, negative 42, woo, and 12 woo. What's that? 30. 30 woo. Negative 24w. Apparently there's no other w. Yeah, that makes sense. Simple as that. All right, let's plug it into the computer here. Woo minus 24w minus 12u. All right, please get it right. Yay! Perfect. Continuing on. A pole that is 3.1 meters tall casts a shadow that is 1.13 meters long. At the same time, I'm going to eat a carrot. I've got 1 carrot left. At the same time, a nearby tower casts a shadow that is 46.5 meters long. How tall is the tower? You know, I feel like the sun isn't that close in this equation, but whatever. Let's see. Next time I will copy your math work, and at September 4th I'm going to show my teacher my work. Oh, okay. Yeah, you can copy my work, just don't look like you copied my work. Carrots are good, man. Okay, so we have a pole with a shadow and a tower. So we're gonna have the same angle. We're gonna know these lengths. So basically, we know this length, and we know we have a right angle here. So it's kind of like figure this one out to get this one, right? Okay. So they set it up as height over. Why is this over y? Oh, height equals length. So height equals length over the other height equals the other length. Cool. Use cross product method. That's cool. In other words, math it out, and you get this y equals that. Carrot. I'm running out of carrot. It's my last one. I like carrots. They're good. All right. So let's see. So that was height over height equals length over other length. I use capitals and not capitals, although they probably look almost the same. Yeah, so that gives me 3.1 over y equals 1.13 over 46.5. That's probably not a very good 5, but there we go. Alright. Sorry, I was itching my eye while I wrote the 5, so I wasn't even looking. Okay, a pole that is that tall has a shadow that is that long. Nearby building has a shadow that long. How tall is the building? So I can see how this would actually be super useful, because let's say, you know, you're, I don't know, in Italy and you want to know how tall the Leaning Tower of Pisa is. So you measure the length of the shadow, the Leaning Tower of Pisa, and you and then you take a 10-foot pole, like you know how tall the pole is, and then, you know, set that up at the same angle, measure that, and then yeah. Then you can find out how tall Leaning Tower of Pisa is. As for why it hasn't fallen over yet, well, probably some smart people. I'm getting distracted. Okay. So in this case, a pole that is 3.4 meters tall equals a shadow that is 1.46 meters long. And it's a 1-to-1 relationship, so we should have, let's see, so the height is unknown for the building, but we know the shadow is 43.5 meters long. Yeah. Okay, then we just gotta map this one out real quick. So how do we do that? So it's over y. So yeah, we're just gonna cross product like they said. So 1.46 y. In case you're wondering really how that works, like it's just multiply across. But what we're doing is times y, so the y goes over here and this has nothing, then times 43.5, so that gets rid of it here, but then it puts it over there. So yeah, we need to get a calculator out for this. So TI-30 to the rescue. Unfortunately, it's covering my math. Okay, so 3.4 times 43.5, 147.9. Then we, oops, 147.9. We need to divide that by 1.46, so that y will be happy. 0.3, or 30 if you like. And round to nearest meter. Oh, okay. So 101 meters. Hooray! Alright, we got a few of these to do, so I might need a new piece of paper. Erebus, God of Darkness. Welcome to the stream. Frank wants to measure the width of a river. Okay, Frank, you like rivers or something. You know, I'm thirsty. Now that we're talking about rivers, so I'm gonna get a drink of water real quick. I'm just gonna hold my webcam. I'm gonna be upside down for a minute. Okay. Let's set up the camera again. Hello, upside down. Okay, that seems to be solid. Solid right there. Alright, Frank, what are you doing? Frank wants to measure the width of a river. He marks off 2 right angles as shown in the figure. Cool. The base of the larger triangle, oh, we're gonna need a new piece of paper for this. The base of the larger triangle has a length of 61 meters, and the base of the smaller triangle has a length of 25 meters. The smaller triangle is 23.9 meters. How wide is the river? And I realize the problem is cutting off on the screen. Well, that's dumb. Alright, well, I'm going to do this instead. Yeah, okay. I'm going to get a new piece of paper. Okay. I think this will work. Nubified. Why does Frank want to measure the river? We may never know. Probably something to do with Sally. Thank you for this amazing content. Don't see many math streams. Well, Bishop M, I'm surprised anyone's watching it, but here we are. That's what happens when you're a college student and a YouTuber, I guess. All right, let's figure this problem out. So we have some numbers for these triangles. And we want to figure out how wide the river is. So really what we have here, both these are 90-degree angles. We have this and that, and that. So if we set it up just like we did before, we're gonna go, let's see, the other one was length, no, the other one was height over length, right? Yeah. It was height over height equals length over length, because, you know, it'd be like a one-to-one relationship, right? So height over height equals length over length. What's one of our heights here? 23.9. That's like a terrible 2. Just whatever. And that's going to equal its respective length, 25 meters. The other length is 61 meters. So what is the other height? The world may never know. Except we can math it out. So we're going to do our little cross product here. So 25y equals, whatever the calculator tells me. 23.9 times 61. It's a big number. 1457.9. 1457.9. Okay. Then we gotta divide that by 25, so y gets all lonely. 58.316. And let's see. Round your answer to the nearest meter. So forget about that end stuff, it's just 58. So, Frank, I'm pleased to tell you that the width of the river is 58 meters. That's a huge river, by the way. Hold on. Hey Google, how many meters, hold on. Okay. Hey Google, how many feet are in 58 meters?
58 meters is equivalent to 190 feet, 3.465 inches.
Okay, so it's almost 200 feet. That's a huge river. Actually, how big is the Mississippi? Okay, Mississippi's not that big. Hey Google, how wide is the Mississippi River?
According to American Queen Voyages, at its skinniest point, the river is between 20 and 30 feet wide, but at its largest, the Mississippi River is more than 11 miles wide.
So this is bigger than the Mississippi River at some points. All right. Frank wants to measure the river so he knows how long it will take Sally to sail across with her smuggling vessel. Oh, Sally. It's from the whole PEMDAS thing. Please excuse my dear Aunt Sally. All right, 58 meters was correct, which is awesome. Okay. So we got a pole and a shadow. So let's. Oh, I smudged. All right. Well, it's stuck on the calculator. I smudged. Okay. Bring this up here. Rub my eye. My eye has been itchy all day. How many meters are in 58 meters? Well, Bishop M, I think it might be 58. I don't know the formula for that, though, so we might never know. Okay. I'm trying not to bump the camera too much. The bottle's right there. Why is my eye so itchy? Stop! Okay. I'm being assaulted by nature. It doesn't want me to do math. All right, so we just gotta find some heights here. Let's see. It was length. Length equals height. Length, height. What was my formula again? Height over height equals length over length. That was it. Height over height equals length over length. So, to do this here, all right, what's the height of the pole? A 7-foot pole. Okay, so 7 feet with a shadow length. Oh, the pole is exactly covered by the shadow of the building. Oh, this is a twist. So the building shadow is 175 feet. So we don't know that one, but we do know that the building shadow is 175 feet. The pole casts a shadow. Oh, we do know this one. That is 6.5 feet long. Okay, 6.5. And we want to know how tall the building is. All right. My question is, how on earth did anyone invent algebra and all these other forms of advanced math? You'd have to be one smart dude to come up with this stuff. Oh, really? Hey, Google, who invented algebra?
Al-Khwarizmi. According to Encyclopedia Britannica, Al-Khwarizmi is famous for his mathematical works, which introduced Hindu-Arabic numerals and algebra to European mathematicians. In fact, the words algorithm and algebra come from his name and the title of one of his works, respectively.
Wow. I've never heard this name in my life. Al-Khwarizmi. Khwarizmi. It's an interesting name for sure. Anyway, yeah, how do you come up with this stuff? You get a pole in a building, plug some numbers in, and see if it's reliable. That's how you come up with math equations. You just have a problem, you solve it, and then you see if you can take that and apply it to another problem and get an accurate answer. Anyway, let's math here. So 7 times 175, I can't be bothered. 1225. 6.5 y equals 1225. Then let's reduce that down a little bit. Divide by 6.5. Y equals 188.46. Probably doesn't care about the 46. Yeah, nearest foot. All right. 188 feet. Yeah. Awesome. Hey, we did it. All right. I think I can put this back over here. Put this back here. Yeah, that's about right. All right, solve for the inequality. Oh, solve the inequality for W. Ah, that's easy. How many meters pandas are? Hey, Google. How tall is a panda in meters?
A panda that is adult and at shoulder is between 60 and 90 centimeters tall.
60 to 90 centimeters. All right. So a little less than 1 meter. I'm getting distracted. Solve the inequality for W. So yeah, we just got to map this out. So we, first of all, get rid of this 5, right? Yeah, multiply everything by 5. And then, you know, this W is going to hop ship. Well, minus 3W from both sides. So it's just going to hop out of the equation, basically. And it's going to take a little bit of that W with it. Move the 45 over. And then, you know, yeah. Now we multiply by 5. If we were to divide by a W or something, we got to, or divide by a negative, that's it. That's where we got to worry about flipping this, but we did not have that, so it's all good. Okay, let us move on here. Solve the inequality for V. Okay, so alright, V, what are your secrets? Always write out the problem first. Okay, so first fraction needs to go away. Sorry about my microphone. Now my nose is itchy. I swear I'm being attacked by nature tonight. So we're going to multiply everything by 7. And that's going to give us negative 6v minus 9 is less than negative 28v plus 14. Next thing to do is move over the 28v, so plus 28. We get 22v minus 9. That plus doesn't need to be there. Move over 9, 22v less than, so plus 9 to that one. 23, that's gonna be awkward. So v is less than 23 over 22. It was almost a clean number. So close. Oh, I guess I should do v equals. Do I have to do v equals? Oh, it's not v equals, it's v is less than. Silly. Silly, Joe man. Yeah, so that's definitely 22. Well, hold on. So get rid of the 7. You become 28. Yeah, it's definitely 22. And then that's definitely 23. I think. Oh, wait, no, I'm good. I'm good. Plus 9 over there. 23. Yep. Okay. Always check the work. Check. Uh-oh. Okay, so I went wrong somewhere. Did I write down the problem correctly? Okay, I did write it down correctly. I think this 9 needs to get bigger. Is that, now I'm gonna look back in my book just a little bit. I think I might have applied the 7 to not quite everything. Let's see. Where have I dealt with fraction variables before? Like my arm. It's a nice arm, isn't it? Alright, well I think that's it. My book's not helping me, but I think that's it. That 9 needs to get about 7 times bigger. So when we get to this point, that 9 needs to be about 63 instead. Yeah, so plus 63. 77. So 22v is less than 77. 77 over 22. We can simplify that as 11 over 2. No, 7 over 2. Yeah. Alright, let's check that again. There we go. Okay. Now that we got the flow here, continue onward. Alright. Negative 2u plus 5. That plus sign all nice and plussy is less than negative 4 over 9 u minus 3. Alright, so we gotta multiply by 9. Multiply by 9. This less than looks terrible. Alright. So we're gonna have negative 18 u plus 45 is less than negative 4 u minus 27. All right. So first thing, make that u go away. So we're gonna plus 4u. So minus 14 u, and then let's see, negative 27 minus 45. 72. Except it's negative. Now we're going to divide by a negative 1, which is going to do a little flippy thing here. So, Gamer Bread, welcome to the stream. Math! Yep, that's right. We're doing math. Alright, so yeah, divide by negative 1, get rid of the negativity here. It's going to flip the sign here. And then we're going to have negative 72, just kidding, positive 72, haha, over 14. Well, let's see. We can at least get it over 7. What's that? 36 over 7. Yeah, that doesn't reduce down anymore. So, we got u is greater. U is greater than 36 over 7. I hope it's right. Yay! All right. Continuing onward. Negative 2 over 3 u plus 2 is greater than 4u minus 5. Okay, so what are we going to do here? We're going to multiply everything by 3. Negative 2u plus, no, just kidding. That's going to be a 6. Plus 6 is greater than 12u minus 15. All right. Then, you know, it'd be easy to get rid of this one, but I want to get rid of this one because I like keeping my u on the left side. So I'm going to do that. So minus 12u, negative 14u, and then we have a plus 6. So we're going to minus 6 from that. So negative 15 turns into negative 21. And then we're going to do a flip again. 21 over 14. Well, obviously that's going to turn into 3 over 2 because divide by 7. So yeah, u is less than 3/2. Awesome. Nice. 6 topics learned. All right, lines and systems. I like the lines one because it usually goes quickly. So y is greater than 4x minus 1. So minus 1, rise 4, run 1, and then it's greater than, so we're going to shade that side. Easy. I don't know what's with this whole 3 thing. Oh, if you were to replace y with 3 and x was 0, then it would be true. All right. So, graph that. So, first things first. Actually, is the first thing first. That, I think we're going with the region here. We're not going with points. So, y is going to be minus 3. Oops. we just start over. Okay. So, negative 3 is 1 point. And then we're going to have a rise of negative 4. Right, a run of 1. And then y is less than that. So, shade that. And I think that's good. No, okay. We messed up somewhere. Y is less than. All right, chat, where did I mess up? Because I'm not seeing it. So let's see. So graph, right? So negative 3 is the y-intercept. And then rise over run for the x. So 1, 2, 3, 4, 1. And down 4 over 1. Y is less than. Is it the right side? Why would it be the right side though? Wouldn't that be greater than? I'm in a little bit of a twist here. I do not know. Well, I need an explanation here. What did I do wrong? All right, teach me. So, we went to negative 3. 1, 2, 3, 4, 1. Okay, so we got the... Oh, I had a solid line. That was the problem. Okay, you got me there. All right. Albino buffalo. If we're all good and eat our vegetables, maybe next week Joe will teach us about the Crimean War or the Great Depression. Which Crimean War? I'm going to leave that alone. All right. Well, now that I know about the whole dotted line thing. So, down 2. And then a rise of negative 1. Run of 2. Right? Yeah. And then it will be a solid line. And y is less than or equal to that. Less than or equal to. It's a solid line. Awesome. I think we got it now. All right. And then this is the same one we got before. 1, 2, 3. Except this is a rise of positive 4. Run of 1. We'll make that a dash line. And then y is greater than that. Wait. Oh, when it's greater than or less than, is that a vertical or a horizontal? It's greater than, right? So it's above that line. Okay. I was right about that. I was unsure for a moment. Okay. Continuing onward. Radical expressions. Riptide, welcome to the stream. Hey, Joe Man. Hey, Riptide. Simplify 54y to the 8th. So we're going to pull y to the 4th out of that, right? And then, yeah, a 3 and leave a 6 behind. Okay, that's simple enough. Yeah, when you have an exponent in a square root or any kind of root, it's like that exponent is divided by that root, because you could break y4 and y4 out of that, and that's what comes out. So, yeah. Okay. I'm gonna get a new sheet here. And let's do some math. Let's do math. That is not as cool as Yu-Gi-Oh! Makes it sound. Okay, 20 u to the 12th. Alright, I mean, u to the 6th and u. It's a terrible u to the 6th. Those break out easy enough, right? And then 4 and 5, we break 2 and 2 out of that. So we're gonna get 2u to the 6th, square root of 5. That should be it. 2u to the 6th, square root of 5. Yep. Check. Awesome. Move over History Channel. Joe Man is coming to town. Yeah. I don't know. Does the History Channel still do history? I thought they were doing like Mountain Man shows or something these days. I don't know. Square root of 18 x to the 6th. I'm not even. I know we pull a 9 and a 2 out of that, so 9 x to the 3rd square root of 2. And writing it out is important sometimes, but I got this. This is gonna be really embarrassing if I don't got this, but I got this. Wait, I don't got this. Whew, that was a close one. 3. You pull a 9 out, but that breaks down to the 3s. All right, that's a 3 right there. Okay. That was almost very embarrassing. Hey, Jamman, you studying for a test? Yes, I am. ISO strike. I'm getting encouragement to keep it up. I hate polynomials because they take so long. All right, so factoring a polynomial by grouping. Problem type 1. How many types are there? All right, wait, what's that say? Oh, it's just same thing. Factor by grouping. So you take your thing and you figure out grouping. So first bit and second bit. And then what do? You pull x squared out of that, and you pull 2 out of that. And then guess what? Those are the same now. Haha. And so then you can have that same one times x squared plus 2. So, yeah. All right, I think we got this. So let's write out our problem. 2y to the 3rd plus 7y squared plus 4y plus 14. Okay, so if we group this, that gives us 2y cubed plus 7y squared in one group, and the other group 4y plus 14. So we gotta pull this out right here. So I'm thinking we got y squared. We pull that out. And then we got 2y plus 7. And then over here with this other one, we pull 2 out. And we get y. No, we get 2y plus 7. So then we can rewrite that. Y squared plus 2 times 2y plus 7. I think that does it. So y squared plus 2. My mouse is over it, I know. times 2y plus 7. Close that up. That exponent makes these parentheses way big. It makes me feel like it's somehow gonna not be equal or something. What does plates and bows are made of clay or plastic? What? Playing your homework streams makes me feel like I'm being productive. Yes, Devlin. Yeah, listen to my streams. They'll make you smart. Maybe. Probably not. Alright, I think this is right. And it is. Awesome. We have to do at least 2 more of these. Maybe more if we get them wrong. So, continuing on here. We got 15v squared. Oh, that's not a square. That's a fifth. 15v to the 5th plus 25v to the 4th minus 21v minus 35. Okay, so just imagine there's parentheses. Well, you don't have to imagine. Just stick some parentheses there. Okay, so now we gotta pull stuff out of that. So v to the 4th can get pulled out of this one for sure, but we can also pull 5 out of it. So I'm gonna pull 5v to the 4th out of it, and that's gonna leave 3v plus 5. And then this one, if we want to get 3v plus 5, I think we can do that. What do we got to pull out there? So 3v plus 5. So that's going to be, it's going to be a negative number for sure. Negative 7. Negative 7. That checks out. Okay. 5v to the 4th minus 7. 3v plus 5. I think that's it. 5v to the 4th. We forgot our parentheses. 5v to the 4th minus 7 times 3v plus 5. I think that's it. Hooray! Alright, and then if I get it right, this will be our last one in this particular category. I feel like it's kind of skewed. Like that looks upright, but if I go by the spine, the text looks slanted. But I don't know, man. Whatever. 5w to the 3rd minus 4w squared plus 5w minus 4. Okay. So we just toss a little grouping on here. So, I mean, these are incredibly similar. This might actually be kind of hard. I can pull w squared out of that one. 5w minus 4. The problem is I don't really pull anything out of that. 5w minus 4 again. So I'm pretty sure I gotta do a plus 1 in here. W squared plus 1 5w minus 4. Because then this w squared would apply to that and that, plus, which we had in our original one, plus 5w minus 4. I'm pretty sure that's it. I had to toss that plus 1 in there to make it work. Group the 5 w's. Yeah, it's kind of what we did. Okay, so we got w squared plus 1, 5w, no, we want minus 4, 5w minus 4. I think that'll do it. Check. Hooray! Yo, we're on a learning streak. Learning so good. All right. Oh, that looks incredibly complicated. All right. For those that are new, I normally do about 2 hours of this, so I've got about a half hour left. The functions f, g, and h are defined as follows. So we have 3 functions that we care about. Wait, find f of that. So we just toss a -2 in place of x. G of that. So 9 goes right there, and -5 goes right there. Oh, okay, that's not so bad. So we toss the numbers in. So f is that, and then you can math it down. G is that, you can math it down. H, okay, it's not so bad actually. Yo, I'm back, just drank a lot. Well, Arbiter, I can only imagine from your name that you might drink a lot. Okay, I might be able to do this horizontally and fit it on one page. We will see. So I am going to write them with the numbers filled in here. So f of x, so we're going with -2 in place of x squared plus 2 over -2 squared. And we're going to go horizontal with this. We might have a hard time fitting this. Let's see. All right, and then g can be -6 plus square root of -3 plus 19. Well, that's 16, which is 4. -6 plus 4 is -2. We'll come back to that in a minute, even though I just solved it. H, 3, absolute value, -11 plus x. So we're going to be multiplying that in a minute. Oh, wait. In place of x, we got 4. Okay, let's go horizontal with this, starting with the first one. I find it helpful to group the similar coefficients rather than the exponents. I mean, you know, however it works. You find a way that makes it easier to math, do it, as long as it comes out accurate. Alright, so this one, -2 squared is going to become a 4. -3 times 4 is -12. -12 plus 2 is -10. -10 over 4. And then, let's see, -10 over 4, that's 5 halves. Yeah, -5 over 2. Alright, and then this one, -3 plus 19, really, that is 16. Pull 2 4s out of that, so that's 4. -6 plus 4 is -2. Easy. And then, what did I even write here? Oh, that's 11. It's -11. That is terrible. It looks like an H, maybe, or an N. Okay. So, 11 plus 4, well, -11 plus 4. But that doesn't give a very nice number. Oh, wait, no, it's fine, because it's absolute value. Okay, yeah, 11 plus 4. -11 plus 4. Why can't I do this? That's 7. So 3 times absolute value of 7, so it's gonna be positive regardless. It's 21. Yeah. What did Xbox came out 2001 or 1998? It's 2001, right? Because that was the great release of Halo Combat Evolved on the Xbox, right? Hey Google, when was the Xbox released?
Xbox Series 10 and Series S's introduced date is November 10th, 2020.
Well, that's the wrong Xbox. Hey Google, when did the original Xbox release?
Xbox release date is November 15th, 2001.
Haha. There we go. Okay, I just gotta plug these answers in real quick. Negative 5 over 2. And negative 2. Really, they're just fitting 2 problems in one. Or, no, 3 problems in one. And I got them all right. Awesome. I'm gonna get a new sheet right here. I don't think we can very well fit another one. Yeah, there we go. All right, math. Here we go. So what am I doing? Yeah, same thing. Oh, this one's throwing some more fractions in the mix, though. All right, so F. Yeah, I'm gonna write it off to the side here. 5 plus square root of 7 plus 7 plus negative 4. 7 minus 4, really. And then G is going to be and X is going to be 4 in this case. 4 squared plus 4. 4 plus 8. And H is going to be negative 1/3. That's a fun number. So square root of negative 15, writing that weird, plus 12 times negative 1/3. Okay. So I guess we'll go top to bottom here. They're just fitting as much math into this as they can. It's 3 problems, not 1. I'm solving 3 problems for this question. So 7 plus negative 4, 7 minus 4, that is 3. Wait. X minus 4, it's 7 minus 4. 5 plus square root of 3, you can't pull anything out of that. Huh. Well, I mean, it's 5 plus the square root of 3. I'm not sure you can really do anything with that. Well, that didn't come out as cleanly as I had hoped. Oh well. Alright, and then G. 16 plus 4, that's 20. Over 4 plus 8, that's 12. If we divide that by 4, we're going to get 5 over 3. Getting a lot of 5s and 3s. Maybe there's a theme to this question. Alright. So then 12 times negative 1/3, we're going to get negative 4. So negative 15 plus negative 4, negative 19. But absolute value makes it 19. Simple enough. Yeah. Okay. 5 plus square root of 3. It's like 5 plus x, you know. It's not 5x, it's 5 plus x. Can't do anything about that, unfortunately. This one is 5/3. This one's just 19. I hope I get this right. Yay! Awesome. I did not like that. I did not like that one. No. Hooray, parabolas! Graph the parabola. Plot 5 points on the parabola. The vertex, 2 points to the left and 2 points to the right. Then click the graph a function button. Okay, so basically here, so if y was 1, no, if y is 0, then x is going to be, yeah, how do we do parabolas? I can't remember the whole thing. So some open upwards, some open downward. So first we start with the vertex. And the vertex is the point at which the parabola turns around. All right. So how we do this is we take some x's, and I guess we just sort of plug them in, -2, -1, 0. Now we're going to fit 5 problems into one problem. So much. Man, I want a carrot right now. I ran out of carrots. Okay. So we plug those numbers into x, and then we get those numbers out. So if x is -2, then y is going to equal 1. So this is going to be kind of a shallow one. So if x is -2, y is going to be 1. So then we get our thingies, and then yeah. So then we have some coordinates, and we put those in, and then it graphs the thing. Okay. So gotta plot some points. So we are working with y equals 1/2 x squared. And if we had like +5, it'd just shift the thing up. +5. Simple as that. Okay. -2, -1, 0, 1, 2. So if x is -2, if x is -2, -2 squared is 4. Half of 4 is 2. So y equals 2. -1. 1 squared is 1. Half of 1 is 0.5. I realize this is kind of redundant because I'm just writing these numbers twice. Okay. All right, so -1. Plug it in again here. Square it, you get 1. So it's 1/2. All right, you plug 0 in, you square 0, and you still get 0 and 0. Yeah, it's going to be 0, 0 unless there's some sort of plus thing after that. Yeah, you plug your 1 in, you're going to get 1/2 again. And 2, I have a sneaking suspicion this is going to come out as 2. 4, half of that is 2. Okay, so we got our numbers here. Now let's plot some points here. Plot a point. Enter the x and y coordinates. Can I just put them on here? Like, so x -2, y 2. Yeah, this is way easier. X -1, y 1/2. Oops. Wait. X1. Okay, yeah. X2, Y2. All right, graph a function. Perfect. Yeah, looks good. Awesome. All right, let's do this whole deal again. So we got y equals 2x squared. Okay, plot 5 points on the parabola. So I'm just gonna this is so dumb. Well, it's not dumb, it's so repetitive, you know. Just work my way down. That comma's not in the right place. It's a big comma. All right, -2. So plug that in. -2 squared, 4, 8. Oh, it's gonna be a skinny one. negative 1 squared, 1, that's 2. 0, 0. 1, that's 2. The thing about parabolas is it's just going to be the same. So like, I know this is 8 before I even plug it in. So, yeah. Let's plot this on the chart here. So, x negative 2, all the way up at 8 here. Negative 1, 2, 0, 2, 8. Graph a function. Check. Mate. Get it? Checkmate. Okay. I'm on a learning streak. Aw, man, more word problems. We are getting near the end here, so yeah. I realize this kind of cuts off. You know what? We'll just go full screen here. 2 trains leave stations 180 miles apart at the same time and travel toward each other. One train travels at 70 miles per hour, while the other travels at 80 miles per hour. How long will it take for the 2 trains to meet? That's a good question. Do not do any rounding. So in other words, use fractions or whole numbers. Got it. All right. It'll take box hours. One train travels that, the other is that, miles per hour. So it is that many miles per 1 hour. Yeah. You can divide that by 60 and get how many miles per minute. So that's cool. 180 miles apart. 180 miles is the sum of the distance traveled, right? So 180 equals 70x plus 80x. That makes sense. 150x, 1.2 hours. All right, I'm gonna write this down. I should probably switch my camera back. There we go. Well, I guess I'm not... Okay, I should write this down for when I do my own problems. For a moment there, I'm like, this is just a practice. I don't need to write it down. I should. Let's see. So... let's say t, which is total, equals at speed 1 plus speed 2. 180 equals 70x plus 80x. Let's see. Yeah, so x equals 1.2, basically 1.2 hours. All right, let's do it ourselves. So, same thing. We're gonna have 192 miles apart and 85 miles per hour. 85 miles per hour. 75 miles per hour. These trains are going just a little faster. So really what we have here is 192 equals 160 x. So we'll have 192 divided by 160, which is going to give us 1.2. That's convenient. So x equals 1.2. Do not do any rounding, even if it's a million digits long. It's not, but yeah, 1.2 hours. Awesome. Okay. I think we got enough room just on the side here. So 340 kilometers apart. 16 kilometers per hour. Wait, one car's rate is 16 kilometers per hour less than the others. Oh, they're... Okay, we're gonna need more space. They're swapping it up on me. Okay. So, we gotta figure out a new formula here. Maybe. So we know that it is 340 kilometers apart. We know that part. And then traveling towards each other. One car is 16 kilometers per hour less than the other. And they're going to meet in 2 hours. So x equals 2. They're going to meet in 2 hours. Okay. 16x. Kind of got to come up with my own formula a little bit here. I'm trying to think, how can I, like, modify this one? This x down here will wind up being 2 hours, and it would be y minus 16? No. X. Question mark x minus 16 less x. Oh, that's just x minus 16. Okay. Maybe. X minus 16x. We'll try that. No, because we need to factor in the 2 hours here somehow. It needs to equal 2. So half of that. Maybe. I'm having a hard time here. I'm having a hard time. Let's see. One car's rate is 16 kilometers per hour less than the others. Well, let's see what numbers could it be though? So if x equals 2, we have x equal 2. We just need to bring that up to equal 340, right? Whatever, so forget about that for a minute. So if x equals 2, we just need to multiply that up. Multiply that up by 340, right? Well, actually, half of 340. That's 170. So 340 equals 170x. And then we need a difference of 16 kilometers per hour. So plus 8 and minus 8. So 340 equals 178. No. Well, half that, and then plus 8 minus 8. 70 divided by 2, that's 85. 85 plus 8 is 93. 93x. 85 minus 8 is 77. Okay. I am sure rate times time equals distance. Yeah, that's probably the way this was intended. But I think I got it. This is definitely not how this was intended to go. Rate times time equals distance. So the rate here would be x, I guess. X minus 16 times 2. I don't know. Which year of university are you doing in fall? I've been doing university since 2017. It's a hard question to answer because if we go just by year, well, we're in 2022, coming up on fall, so this will be my 5th year. But I'm not a senior. I don't know. Yeah. So one car's rate is 16 kilometers per hour, less than the other. What is the rate of the slower car? It is 77 kilometers per hour. Hooray! I definitely did not answer this the right way, but I got it. Okay. Might have one or two more problems, so we'll probably be ending soon here. To rent a certain meeting room, a college charges a reservation fee of $35 and an additional fee of $6.40 per hour. The film club wants to spend less than $86.20, that's a strict budget, on renting the meeting room. I'm going to blow my nose real quick. Oh boy. Yep, don't mind me. In fact, there's the whole problem. Yeah. What are the possible amounts of time for which they could rent the meeting room? So let's see. So a reservation fee of $35. So 35 plus 640x, right? I think it was as simple as that. Or 640t. Oh, and keep it less than 86.2. Okay. The possible amounts of time. So they could rent it for less, right? Yeah. So 35 plus 640t less than 8620. And then, you know, math it out. So we have t is less than 8. So 8 hours. So as long as they're less than 8 hours, they should be fine. Yeah, okay. That makes sense. Oh, so like part-time. Yeah, most of my semesters, I haven't quite been full-time. Like, full-time at my college is 12 credit hours, and like a full class, like a math class, like heavy-duty kind of thing, is 4 credit hours. So if I did 3 heavy classes, I'm full-time. So that could be like a math class, plus a computer class, plus a geology class. That would be a full-time. I could do more than that, but at least most classes, at least 3 classes. So anyway, I'm going to flip onto a new piece of paper, and we're going to keep mathing this up here. So yeah. Okay. To rent a certain meeting room. It's the same thing. So $34 plus $8.40 an hour. So 8.4. They use T, so I'll use T as well. A little tail at the bottom of the T there. The chemistry club wants to spend at most $76 on renting the meeting room. So, what are the possible amounts of time, aka what is the most time they could spend and not go over budget? Glad there's no taxes to factor in here. Okay. So, at 34, just pop on over. Alright, so 34 to 72, 42. And then we're going to need the calculator for this one. 42 divided by 8.4. Oh, 5. T is less than 5. So as long as you spend 5 hours or less there, they are within budget. Oh, I gotta do it properly here. T is less than 5. Uh-oh. We messed up somewhere. So $34 plus $8.40 per hour. $76. What are the possible amounts of time for which they could rent meeting room? Ah, it's less than or equal to. Ah! Little things like that. Because they could less than 5 hours or equal to 5 hours. They can go right up to that 5 hour mark. So, yeah. Is that it? That's it. Okay. I'm learning. It's always little things, you know? Alright, Teresa is going to rent a truck for one day. Teresa, what are you going to do with that truck? You're going to go meet Sally. There are 2 companies she can choose from, and they have the following prices. A and B. And there's the numbers. So $92 unlimited mileage, or $65 plus 90 cents per mile. For what mileages? Okay, I get it, yeah. For what mileages will company A charge less than company B? So, we're gonna have a less than. So, $92 is less than 65 plus 0.9 M for miles. Oh, use M for the number of miles driven. Okay. So yeah, we'll set it up like that. So we're gonna minus 65 over there. Let's see, so minus 5, it's 87, 27. 27 is less than 0.9 M. We need to bring that up to the list. So 27 divided by 0.9, it's gonna be 30. 30 is less than M, or M is greater than 30. No, greater. Dang it. There we go. Okay. So what was the question? So for what mileages will company A charge less than company B? So in other words, company B, which is the M in this case, is greater than 30. So 30 miles, I think. I gotta blow my nose again. Sorry. Seriously, man, nature is attacking me. Not fair. Okay. So what am I doing here? So use M for the number of miles driven. So what mileage is will company A charge less than company B? A less than B up to 30 miles. How do I write that with M? M is greater than 30? 30 is less than M? 30 miles is less than company B? Let's see here. I'm trying to think how to write this. For what mileage will company A charge less than company B? It's not M is less than 30. Well, maybe it is kind of. So really what I have here is the mileage of company B, like it's more expensive over 30 miles for B. More expensive over 30 miles. I'll say M is less than 30. I am not very confident about this. Let's see. M is less than 30. So less than 30 miles. I'm not confident. Check. Really, it's M is greater than 30 though. All right, I'm gonna recheck that one if it's wrong. I'm curious to see how this goes. It was M is greater than 30, but the problem is this equation doesn't really fit as an answer. For what mileages will company A charge less than B, right? M is greater than 30. You don't, when you're talking about one charging less than the other, you don't use greater than. Word problems suck. Okay, so M greater than 30, we did get that right. All right. For his phone service, Keith pays monthly fee of $21, and he pays an additional 6 cents per minute of use. So 21 plus 6x. The least he has been charged in a month is 87.96. What are the possible numbers of minutes he has used his phone in a month? What are the possible number of minutes he has used his phone in a month? I'm assuming we're talking about in that month where he was charged the least, because I mean, he could just talk a lot more and it's still possible. So we're going to set this up as 87.96. Do we want to do less than or greater than? Okay, I think I know what I'm doing here. So we want 21 plus 0.06 m. All that is less than 87.96. I think this is what we're going for here. And so to accomplish this, I'm going to move the 21 over. Let's see, so why are numbers hard? All right, so we got 108.96. Okie doke, and then you should divide that by 0.06. Gonna give us a lot of minutes. That's 1816. So m less than 1816. I think that's what we're going for. What are the possible number of minutes he has used his phone in a month? Now, the problem is the least he has been charged in a month is that number, which is actually cutting off just a little bit. Hold on. Dang word problems. Okay. Yeah, so the least he has been charged is that. What are the possible number of minutes he has used his phone a month? So I guess technically it can't be less than. It has to be greater than, because he has always he's always used a greater number of minutes than that, never less than it. So we're going greater than on that. Swimmer of age. Doing my homework right now. Alex is traumatizing. Yeah, I get it. Okay, I think what we're going for is greater than 1816 minutes. Yeah, I think so. No, that's not it. What are the possible numbers of minutes he has used his phone in a month? So the least he has paid is 87.96, right? He could have paid any amount greater than 87.96. So this times number of minutes could be any amount greater than 87.96. Let's see. So the possible number of minutes he has used his phone in a month is anything greater than that. Is this Algebra 1? It's pre-calculus, or at least it is preparing for pre-calculus. So well, I'm gonna get the explanation because it's got to be greater than, right? Oh my goodness, it might be greater than or equal to, because that has to be included, right? Is it that? No, it's not that. Okay, we're getting the explanation. So it's that one, and then okay, monthly bill of at least that. So it's greater than or equal to that. Okay, so I set that part up correctly. 21 plus 0.06 m is greater than. Oh, I went wrong. Oh, I plus 21, not minus 21. Ah. Okay. Let's keep going. $88 a month for his phone service monthly fee. What service is he using? Well, back in the day, like 20 years ago, you'd get charged based on the number of minutes you used or the number of text messages you sent. Kind of an incentive to not use that a lot. Anyway. Okay. Let's continue on through here. Store problems are hard because it's not just like, here's the equation, solve it. It's like, figure out what equation you should use and then solve it. Okay, so certain meeting room. Oh, it's the film club wants to spend less than that amount of money. Okay. So $43 plus 7.7 per hour. And they want to spend less than 73.8. All right, I get it. So minus 43 from both sides, right? Don't want to make that mistake again. Let's see. So that's going to drop down to 30.8. 30.8 divided by 7.7. Conveniently, that's 4. Okay. It's going to be less than or equal to. So, possible amounts of time for which they could rent the meeting room. So, T is going to be less than or equal to 4 hours. Must be a really good meeting room. Also, reservation fee of $43. Dang. Yeah. Okay. Check. No! All right, what did I do wrong here? What are the possible amounts of time for which they could rent the meeting room? All right, where did I go wrong here? So, 43 reservation fee. Additional fee, $7.7 per hour. Okay. We want to keep it under $73.8. Okay? $73.8 minus 43. Okay, so we get $30.8. And then we divide that by 7.7, so T can get all lonely. T is less than or equal to 4. What am I doing wrong? Didn't we do this one like right up here? Like seriously. Is it not equal to 4? It's just less than? Man, I'm going to rip my hair out. Oh my goodness. Less than 4 hours. They can't rent it for a full 4 hours though. No. Less than. Man, these store problems suck. Okay. Raina is going to rent a truck for one day. Raina, watch out for Sally when you're on those roads. Okay. So 2 companies. Company A is $111. B, 75.90 cents for every mile. So what mileage will company A charge less than company B? Let's see. 75. My music stopped. Why did my music stop? Okay. So 75. We use M again. Why did I just say again twice? We're going to use M again. 0.9. I mean, we did the problem up here, right? Yeah. Gotta blow my nose again. Ah, man. think so far with all the math stuff, it's only been little dumb mistakes that I've made. But I will say, after this this section, I will probably finish. Let's see. I'm gonna rewrite this problem a little bit. So we want A is less than B. How many for what mileage will company A charge less than B? So A charges 111, and it's less than B as long as we have 75 plus 0.9 M. Okay. So 111 minus 75. We got 36. 36 is less than 0.9 M. Kind of coming off the edge of the screen a little bit here. And 36 divided by 0.9 is 40. Okay. 40 is less than M. Or M is greater than 40. Now last time we had issues here. M is greater than 40 is the right answer. But the problem last time is it was like for what mileages will company A charge less than? Right? Well, I will answer you by saying that company B will charge greater than 40 miles. So yeah. Okay. Well, we got it. we got it. Oh man. Sometimes it's annoying. Okay. Well, we learned 13 topics, and I think we're gonna call it there. We filled out more of our pie. We don't need to fill out the whole thing, but this is prep for pre-calculus. Next thing is graphing a parabola. That looks like a fun formula. Yeah. It doesn't have an equal to in there. It doesn't have to. ISO strike. Okay. Yeah. So, yeah, we filled out a lot of the pie here. Here, let's look at a timeline. Well, this would be a lot better timeline if I could go back. Can I go backward? Like, bro. How do I go back? Timeline detail? Oh, there we go. Okay, that's a better timeline. So yeah, there's that stream, and then there's that stream. There's that stream that Wednesday. What's this thing? Oh, I mastered 65 new topics. Cool. Oh yeah, I think that's when I took my little test thing, the pop quiz. Yeah. And if we look at all, man, look how steep this line is, and it's like, okay, we're gonna aim for this. It's gonna take you till January. I don't know, at this rate, if I keep doing this many per week, probably have it by like October, you know? That's still into the semester. That's too late, but that's all right. How do I get out of this? Let's go back to the home screen. Take me back to my pie. All right. Yeah, so I think we're gonna end it there. We definitely did some math. We definitely did a lot of math. So this might be the last math stream. Maybe. We'll see. I'm gonna focus my camera a little bit. See me better. See Master Chief better. Yeah. This might be the last math stream. I don't know. But later this week, I'm going to take the test for pre-calculus. I'm not trying to test past pre-calculus. I'm not trying to, like, jump over it. I'm just trying to get into pre-calculus. So, I wasn't even good enough when I took the test before. So I'm going to test into pre-calculus, hopefully. If I do, then I'll be satisfied. I will take classes, pre-calculus, calculus, physics. That's all I got to do for my degree. So that's the plan. Anyway, this might be the last math stream because I might not have more math to do if I go that route. I might not have more math to do because I might test high enough and not have to come back to this thing. Also, if my professors don't let me stream my homework, which why would they, then I will also not be streaming that. So perhaps this is the end of the homework streams. In any case, thanks everyone for watching. I am surprised that anyone watched, but I guess I have a talent for making anything mildly entertaining. Anyway, I'm going to switch over to the closing stream song, and we will end the stream. So, thank you everyone for watching. I'm JoeMan543. I do my fun video game streams on Fridays, and I hope to see you there next time. That's 2 days from now. Please be there, because those streams I do actually try to make them entertaining. Anyway, see ya. Bye.